Did you know that most of the electronic devices we use today has some form of logic gates? Yes, for example, computers, mobile phones, televisions, tablets, and even memory devices like flash drives, hard disks, and many more. So logic gate is the building blocks of any digital system. It is an electronic circuit having one or more inputs and only one output. To identify an AND gate, the inputs must be the same together with the output, and if there is difference in the inputs, then the output is automatically false. In OR gate, the same inputs then same output. Different inputs then automatically true output. NOT gate is also known as inverter, a simple logic gate, and single input and output. To identify SOR gate, the output of it is true only when exactly one of its inputs is true. If both inputs false or true, then the output of the SOR gate is false.
Good day everyone, my name is Noel GDS and I'm going to report about the types of logic gates. The NAD. The NAD function is sometimes known as the Schaeffer-Stroke function, and it's denoted by a vertical bar or upwards arrow operator. For example, second is NOR. NOR, which is similar to neither, to make the sentence negative. Example, Maria does not miss a day of work, nor does she miss a day of school. Third is XNOR, application of an XNOR gate. For example, a hallway that has two light switches. If both light switches are in the same position, the light will be off. If they are in any separate position, the light will be on. This sample configuration is a common example of logic gates in everyday life. Thank you.
Good day everyone. Today I will discuss to you about text data. So the objectives of text data is to be able to find the pattern and trends across multiple documents. Second, to be able to process large textual data to extract high quality information which will be helpful to providing insights into the specific scenario to which the text mining is being applied. So text mining have incorporating results, process, applications, numerizing text, areas, approaches, lastly, pros and cons. TDM, or text and data mining, is the automated process of selecting and analyzing large amounts of text or data resources for purposes such as searching, finding patterns, discovering relationships, semantic analysis, and learning how content relates to ideas and needs in a way that can provide valuable information needed. Good day everyone. Today I will discuss to you about text data. So the objectives of text data is to be able to find the pattern and trends across multiple documents. Second, to be able to process large textual data to extract high quality information which will be helpful to providing insights into the specific scenario to which the text mining is being applied. So text mining have incorporating results, process, applications, numerizing text, areas, approaches, lastly, pros and cons. TDM, or text and data mining, is the automated process of selecting and analyzing large amounts of text or data resources for purposes such as searching, finding patterns, discovering relationships, semantic analysis, and learning how content relates to ideas and needs in a way that can provide valuable information needed.
Good morning everyone, I'm Donamia Stoll and now I will give an example of decoding and encoding. So this is the example of decoding and encoding. So what is sender, encoding, message, channel, decoding, and receiver? So sender is also called the source. Sender or source of a communication is a person or organization that has the information with another person or a group. Encoding is a communication process begin with the source or sender selects words, symbols, picture like to represent the message that will deliver to the receivers. Message and channel. Message is encoding process leads to the development of message that contain the information, while channel is also known as medium. It is the way by which sender conveys the message to the receivers. Decoding, just a sender encodes the message, the receiver must decode it. And lastly, receiver is the party for whom the message is intended. It is an active part for communication.
Hi, this is Karen, and I was assigned to report the encoding and decoding together with Mrs. Stoll. Encoding. So in order to convey meaning, the sender must begin encoding, which means translating information into a message in the form of symbols that represent ideas or concepts. So encoding as an element of communication is the process of assembling the message such as informations, ideas, and thoughts into a representative design with the objective of ensuring that the receiver can comprehend it. Three types of encoding or levels of processing. So first is visual, the encoding of picture images. So visual encoding is the process of encoding images or visual sensory information. So this type of information is temporarily stored in iconic memory and then is moved to long-term memory for storage. Second is acoustic, the encoding of sound. So acoustic encoding is the use of auditory stimuli or hearing to implant memories. This is aided by what is known as the phonological loop. Third is semantic, the encoding of meaning. Semantic encoding involves the use of sensory input that has a specific meaning or can be applied to a context. For example, you might remember a particular phone number based on a person's name or a particular food by its color. Next is decoding. Decoding, it is a process of converting a message into thoughts by translating the received message into an interpreted meaning. So decoding of the incoming information is a translation piece. Translation of the message occurs depending on the channel and complexity of the message. So decoding is listening and reading directions carefully.
Repetition code. Among the simplest code are repetition codes, where each code word consists of a single symbol repeated many times. The length n repetition code is used over and over again. As a result, the N1 code, for example, the length for repetition code over 0, 1, 2 is 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. Hamming codes. A family of linear error correcting codes known as Hamming codes. Hamming codes can defect and repair 1-bit and 2-bit faults while ignoring uncorrected errors. The simple party code, on the other hand, is incapable of correcting faults and can only identify an odd number of them. Hamming codes are perfect codes, meaning that they obtain the best achievable rate for codes with a block length or 3 blocks and a minimum distance of 3.